But I need to figure out how much money do I need to afford those. But we already recognize that that is the present value of that 25 years worth of 5,000 plus the balloon. And we know how to make that calculation. Come on, mouse. Don't embarrass me. Now, okay, now mouse is creating a problem. I'm serious. Somebody's screwing with me. Okay. First and foremost, since I'm going to calculate a final value, I'm going to get this out of solver mode. Okay. So that becomes a red light if you double click on it. And I want present value, so that's already done. Now, I don't have to worry about target value. My interest rate during retirement is 3%. Okay. I'm going to collect those for 25 years. How many payments I'm going to be collecting every year? It's monthly, so 12. What's my periodic payment? 5,000. What's the balloon I want? 3 million. So it already calculated the left-hand side formula for me, okay? That is the present value of 25 years worth of 5,000 plus 3 million balloon payment at the end of 25 years. Okay, that's how much I need to have when I retire. Now we're going to ask a different problem. I know how much I need, okay? The only thing I don't know is how much do I need to save per month. So for the next 40 years, I'm going to be saving an unknown amount, okay? While earning 8% APR. And I already have $25,000 in my account. So what am I going to do? A future value or present value calculation? I know what I need at the end, okay? So that's going to be a future value calculation. So convert this into future first. All right. Oh, before that, I mean, this was already here. I guess we solved it last time. Copy that target value you had, because that's how much you need in your account. Paste its value to target value. That's my target. Let's convert this to future. All right. Now I'm gonna be earning 8%. Oops, my keyboard embarrassed me again. 8%. No, Control Z, Control Z. For 40 years, monthly savings. I don't know what it is yet. I haven't solved it. That 5,000 sits there just as a placeholder. And my starting balance is 25,000. Okay. I mean, at this point, I'm not in solver mode yet. This says if I save $5,000 a month, and I started with 25, I'm going to end up with $18 million at the end of 40 years. Okay. But that's not my target. It's too much. Ideal, you could do manual. How about $1,000? Even that's too much. That's a little bit too little. But we're civilized people. We're not going to do trial and error. There's nothing wrong if that's what you want to do. But Excel internally is essentially doing that anyway. So the answer is somewhere between 500 and 1,000. Okay. If I was doing by hand trial and error, I would have tried 750 next. That's too much. 625. every time you have the bracket, this is called a bisection. This algorithm has been known since the times of at least Euclid, who was a Greek mathematician in Egypt around 300 BC, a few decades after Alexander the Great actually conquered Egypt. Euclid. He, he invented Euclidean geometry, the geometry of flat spaces. A lot of things that you know about triangles, similar triangles, a lot of different theorems in geometry are from Euclid. Oh, he was a genius. Back in, around that time, he proved with a very good logical argument that square root of 2 cannot be written as ratio of two integers. It is an ingenious argument. You guys want to know? It's simple. That argument became mainstay of some of the mathematical proofs. He basically said, suppose it can be, okay? So you can write square root of 2 as a ratio, of course. OneNote thinks I'm actually making a calculation, P over Q, and P and Q are integers, okay, whole numbers. And let's assume that this ratio is irreducible. For example, 2 over 4 is not irreducible. You can reduce it to 1 over 2, but 1 over 2 is irreducible, okay? And there's no generality loss with that assumption. If P over Q is a reducible ratio, and that's equal to square root of 2, and then the reduced version also would be square root of 2. So we're going to assume that it's irreducible. You cannot reduce it any further. Okay. Now, square both sides. And this will imply 2 equals P times P divided by Q times Q, or P times P equals 2 times Q times Q. This immediately implies that P has to be an even number, okay? No odd number has a square that's a multiple of 2, okay? So square of P is an even number. That means P is an even number. Think about it. 3 times 3 is 9. Any odd number, hence P must be even. Thus, you can write P as 2 times K for some K greater than 0. I'm assuming they're positive. You could also do negative. It doesn't change anything. Okay, if that's the case, then let me see. Let's see. P squared is going to be 4 times K times K, which we know is already equal to 2 times Q times Q. Cancel the 2's. Q squared is equal to 2 times K squared, okay? Hence, this implies Q times Q is equal to 2 times K times K. Thus, Q must be even. But they're both even, I can reduce P over Q. I had assumed that I could not reduce it. Hence, my original assumption must be wrong because I assumed that I could write square root of 2 as ratio of two integers. In math, this is known as the method of reductio ad absurdum, okay? Reduction to absurdity. You have a statement, you assume it's not correct. Then you follow its logical conclusions. It turns out its logical conclusions is absurd. Now, if that's the case, then your original assumption must be wrong. If the end is, something weird, the beginning cannot be correct. That was it. This guy did this 2,300 years ago. And they did not have any symbolic algebra or anything. He basically described things in words. The guy who invented algebra, his name is, he's a Muslim mathematician, probably Persian, Al-Jabir. Okay, that's where algebra comes from. And I actually read some of the stuff he wrote. There's not a single symbol. Okay, he simply describes everything by words. Symbols came around 10th, 11th century. The use of X, for example, came, I think, 12th century. There is another Persian mathematician is responsible for algorithms. The word algorithm is actually they transliterated the word wrong from Arabic script. His name is, he was from the city of Harazm. Okay, so he was Al-Harazmi, which means the one who's from Harazm. But there are two sounds in Arabic, G and Kha, and the letters for each are very similar. So whoever was transliterating it read it wrong, so the word became algorithm instead of Al-Kharazmi. The name of Beetlejuice is like that. Beetlejuice was in Arabic is named Yad al-Jawza. It means shoulder. Arabic name for Orion is Jawza. Yad al-Jawza is shoulder of Orion or arm of Orion. But in Arabic, the letter B, you have a little thing, a single dot. The letter Y, a single thing, two dots underneath. But whoever was copying it saw only one dot. Yad al-Jawza has become Beetlejuice.